So basically, I just want to say a few words about these new notebooks that you will have in a few hours. So far, how we handle the data is we used ready datasets from the TensorFlow keras, and we load the data as a tensors, and we store all of this data in a memory. And then during the training, we set the batch size that will create the mini batches and feed to the stochastic gradient descent. The problem with this approach is that is sequential, which means that first we prepare one mini batch to feed to the network, and then when this batch is prepared, we can train our network. Here you can see that it says on GPU, TPU, but it can be also we train on the CPU. And then while we're training the model, nothing is happening with the data, it just waits. And then for the next batch, we have to prepare data again, and the model is not doing anything, it's just waiting. And as you can see, there are a lot of waiting times. And it would be good to create a process that could prepare the data while the model is training in parallel. So for example, you prepare the first batch, you feed it to the model, and while the model is training, you prepare the next batch. And this is exactly what input pipelines do. And in TensorFlow, it's implemented with module called TensorFlow data. And specifically, we are going to use TensorFlow data dataset objects to create input pipelines. So this module is created on the principle of extract, transform, and load. Basically, what it means that we have some data that we need to first extract. The data can be of different type. It can be images, texts, specific data format like TF record, NumPy arrays, CSV. It can be stored in the local disk or in the cloud environment. Then we need to perform certain transformations which are specific to the data. And in this step, we can also do this data augmentation process that's been introduced today. It can be, for example, random transformations of the images, flipping images or rotating images. We could work also with the text vectorization. And in the same step, we shuffle the samples, we create mini batches and perform so-called prefetch. And then we load our data to the hardware that we have, CPU, GPU, or TPU. So how does it happen? First, we create a dataset object, TensorFlow dataset object. It can be created from different data types. In this case, we have a NumPy array. And you have different methods to extract the data for the arrays, for the text, for the images. And this data object, dataset object, which is called here train DC, which just stands for dataset. It behaves as a generator. So basically you can use for loop to generate the batches. We can create a custom preprocessing function, and we can apply these functions to our data by using map methods from the TensorFlow data module. We can shuffle the data, we can form the batches, and also we do the so-called prefetch. And this prefetch methods is very important. Is basically the step which prepares the next batch while the model is training. And that's why we can do the data pre-processing and preparing in parallel with the model training. This module also provides a very useful parameter or function like an auto-tune to set how this processing is happening. For example, you can apply this map function in parallel to samples, because the samples that we have in a set, they are independent. So we can perform transformation of each sample separately in parallel. We don't need to do it sequentially. And we can set the parameters for this parallel processing with this auto-tune. And also for the prefetch function, you need to set the parameter or argument buffer size, which can be also automatically, the optimal buffer size can be found automatically with the auto-tune. You will have a bit more information and detail about this feature in the notebooks. And then we just create the model and we feed these generators or data sets right into the feed method. We have training data set, validation, and test data set. So it's a bit more complicated, but it, and maybe in our case, it doesn't add much of the benefits. But if you're training very large networks and you have a lot of pre-processing with the data, the normal way would be create this kind of dataset object and create the input pipeline that could automatically generate mini batches. So that's it.
Thanks a lot, Shamsi. Are there any questions?
There will be, of course, more details in the notebooks. There are 3 notebooks. The first one is devoted to this explanation of what is the this TensorFlow data module and how to work with it. And then second one is data augmentation, and third one is transfer learning. And although there is more text to read, the amount of the tasks are less than usual, I think.
Very good. Yeah, please, if you have any other questions, don't hesitate to ask us by email or on the Slack discussion forum. Otherwise, I hope you enjoy the new round on regularization. Have a nice week. Bye.